Have you ever picked up a handful of cool, dark dirt and wondered how long it has been resting there? For most of human history, the ground beneath our feet kept its lips tightly sealed. The rocks could not speak, and the mountains did not keep a diary of their youth. People looked up at the stars and down at the soil, burning with a deep, aching desire to know exactly when our world began. It was the ultimate cold case, a beautiful puzzle that seemed completely impossible to solve without a time machine. Long ago, curious minds tried to find a birthday for the world by reading very old books and ancient stories. They carefully counted the lives of kings, grandfathers, and great-grandfathers, adding up the years one by one on pieces of parchment. By doing this simple human math, they guessed the world was only about 6,000 years old. It felt like a solid, comforting answer. But as explorers started digging deeper into the ground to build canals and mines, the earth itself began to whisper a very different story. People who loved to study the outdoors noticed something strange about the tall cliffs and deep canyons. They saw giant walls of rock made of hundreds of flat, colorful layers, stacked up like a giant pile of pancakes. They realized these layers were made of fine mud and tiny grains of sand that slowly settled at the bottom of ancient, forgotten oceans. To build a massive mountain out of tiny floating grains of sand would take a very, very long time. 6,000 years was simply not enough time to bake that giant rocky cake. The puzzle was soon framed as the grandest riddle of all time. How do you measure time before any human was alive to build a clock? Finding the Earth's age became a thrilling, multi-generational chase. Brilliant minds from all over the world decided to become time detectives, searching for a hidden clue that could unlock the deep past. In the late 1800s, a very famous and fiercely confident man named Lord Kelvin decided he was going to solve the mystery once and for all. He was a master of heat, energy, and invisible forces. Kelvin imagined the early planet not as a green world, but as a giant, glowing ball of melted liquid rock floating in freezing space. He knew that hot things always cool down over time, just like a hot potato left sitting on a cold dinner plate. Kelvin grabbed his pencil and did some very complicated math to figure out how fast a giant rock potato would lose its heat. He proudly announced that the world was between 20 and 40 million years old. Because he was such a famous and respected figure, almost everyone believed him immediately. It seemed like the great mystery was finally solved by the sheer power of human mathematics. But the planet was hiding a magical secret deep inside its belly. Kelvin's math was perfect, but his recipe was missing a huge, invisible ingredient. He did not know that the Earth had a hidden fire, a special kind of energy that kept the rocks warm long after they should have turned freezing cold. The mystery was far from over, and the real answer was hiding in the dark. The story took a wild turn in a dusty room in Paris, completely by accident. A scientist named Henri Becquerel left some strange heavy rocks in a drawer resting right on top of some picture film. When he took the film out days later, he saw bright, glowing spots exactly where the rocks had been sitting. The rocks were glowing with an invisible light, shooting out tiny rays of energy all by themselves without batteries or the sun. Two brilliant heroes, Marie Curie and her husband Pierre, dedicated their lives to chasing this glowing magic. They worked day and night in a drafty, leaky wooden shed, boiling huge pots of heavy dirt to find out why the rocks glowed. They discovered that certain rocks are actually unstable, meaning they slowly break apart into smaller pieces, and as they break, they release heat. This invisible glowing power was called radioactivity. It was the secret fire that kept the planet warm, proving Lord Kelvin's hot potato math completely wrong. But even more amazing, this glowing energy acted like a tiny, ticking stopwatch hidden inside every single stone. When a parent rock breaks down into a child rock, it happens at a very strict, steady speed that never, ever changes. If you can count the number of parent pieces and the number of child pieces inside a stone, you can tell exactly how long that stopwatch has been ticking. Suddenly, the time detectives had a real clock. The scientific community was buzzing with wild excitement. All they had to do was find the very oldest rock on the planet and read its glowing clock. But the Earth is a restless, messy, and constantly moving place. It is always melting its own crust, crushing old rocks under mountains, and spitting out fresh new ones from hot volcanoes. Finding a rock from the very first day the planet was born was like trying to find the very first snowflake in a raging winter blizzard. Every rock the detectives tested was just a recycled, melted piece of a much older puzzle. To find the true beginning, the detectives had to stop looking at the ground and start looking up at the night sky. They needed a pristine rock that had never been melted, crushed, or chewed up by the Earth. They needed a meteorite. These space stones are leftover building blocks from the very birth of our solar system. They have been floating in the freezing, quiet dark of space, perfectly preserved, until they crashed down into our dirt. Inside these fallen space rocks was the ultimate clue. They contained a tiny, almost invisible amount of a heavy metal called lead. Every single piece of lead builds a perfect picture of deep time, acting as the final child piece of the glowing rock clock. If someone could just measure the tiny drops of lead inside a meteorite, the 200-year-long search would finally be over. In the 1950s, a quiet and incredibly stubborn scientist named Clair Patterson stepped up to read the space rock. He was a careful man from a small farming town who loved fixing broken things and solving hard problems. His job seemed simple enough for a smart man. He just needed to wash a piece of meteorite, dissolve it in strong acid, and count the tiny drops of lead floating inside. But Patterson's work quickly turned into a confusing nightmare. Every single time he tested the space rock, the numbers were wild and completely wrong. One day, the rock had a little lead. The next day, it had a massive mountain of lead. It made absolutely no sense at all. He felt like he was losing his mind, chasing a ghost that kept changing its shape. After months of pulling his hair out and staring at broken numbers, Patterson had a shocking realization. The extra lead was not coming from the space rock at all. It was coming from his own laboratory. Lead was everywhere in the modern world. It was in the bright paint on the walls, the pipes carrying the drinking water, the dust on his shoes, and even in his own hair. The everyday world was so dirty with toxic metal that it was ruining his delicate space rock clock. Patterson tried desperately to clean his lab. He scrubbed his glass tubes with boiling acid until his hands ached. He wiped down every table and sealed the windows. But the invisible lead dust kept sneaking in, destroying his hard work. The great mystery of time was being blocked by a tiny speck of everyday dust. Patterson absolutely refused to give up. He realized that to read the oldest clock in the universe, he had to build the cleanest room in the history of the world. He designed a magical bubble, a room inside a room where no dirty outside air could ever enter. He pumped in special filtered air that blew away the dust. He covered the walls in pure, clean plastic. He made everyone who entered wear funny white suits and booties over their shoes. He created the very first ultra-clean lab. Today, we use spotless rooms just like his to build computer chips and life-saving medicine, but Patterson built the first one just to wash a single rock. Finally, inside his spotless plastic bubble, Patterson washed his meteorite one last time. He carefully dissolved the space stone in pure acid. He measured the lead. This time, the numbers did not jump around. The invisible dirt was gone. The clock was crystal clear, and the numbers were absolutely perfect. He took his tiny sample to a special counting machine. The machine hummed and clicked, and then it printed out the final answer. 4.5 billion years. Patterson was so overwhelmed with emotion that he thought he was going to have a heart attack right there in the lab. He rushed home to tell his family. He had finally found the true birthday of the world. Culminating in this massive victory, the story of deep time should have ended right there with a happy celebration. But Patterson was a man who could not let a puzzle go. He kept thinking about all that dirty, floating lead in his old lab. Why was the everyday world so heavily coated in this toxic metal, and was it hurting people? He transformed into an unexpected hero. His scientific quest shifted from the deep past of the solar system to the living, breathing present of our world. He wanted to know if the world had always been this dirty, or if humans were making it worse. So, he packed his bags and went on a grand, freezing adventure. Patterson traveled to the middle of the deepest, wildest oceans. He scooped up water from the very bottom of the sea and water from the sparkling top. He climbed the highest, coldest mountains in the world to dig deep into ancient, frozen ice. He was looking for the history of dirt, reading the layers of snow just like the early rock watchers read the mud. The ice and the oceans revealed a terrifying truth. Hundreds of years ago, the air was perfectly clean. But in the modern world, the air was filled with dangerous, toxic lead. It was coming from the gas we put in our cars and the pipes we put in our homes. Humans were accidentally poisoning the whole planet, and the poison was falling on every leaf, every animal, and every child. The quiet man who found the Earth's age was now forced into the biggest, loudest fight of his life. Giant companies that made the lead gas called him crazy. They tried to take away his job, cut off his money, and silence his voice. They wanted the world to keep buying their dirty fuel, no matter who it hurt. But Patterson was the exact same stubborn man who spent years washing a single rock. He knew exactly how to read the truth, and he absolutely refused to back down. He went to the government and showed them the pure, clean numbers from his ice blocks. He explained that the invisible lead was hurting children's brains and making people incredibly sick. Slowly, the world finally listened to the stubborn time detective. Laws were changed to protect the air and the water. Lead was taken out of the gas that fuels our cars and the paint that covers our bedroom walls. The air became clean again. The toxic dust that ruined his early experiments was washed away from our cities. The journey to find a simple number turned into a massive rescue mission for all of humanity. A multi-generational detective story that started with old books and hot rocks ended with a man whose stubborn curiosity saved millions of lives. The 200-year-long mystery did not just give us a birthday to celebrate. It gave us a cleaner, brighter, and healthier world to live in.